Hey pre-calc students, welcome to today's lesson on a review of anything pretty much having to do with angles and degree measure when it comes to drawing. So if you notice, there's three objectives for today, or three goals. We want to be able to draw them in standard position, so that's the first heading in the notes. We want to be able to find reference angles to a given angle, and we also want to be able to find coterminal angles, okay? All right, so a lot of this stuff you guys have already seen multiple times before, so this will just be a refresher. Okay, when you are drawing an angle in standard position, the vertex has to be at the origin, so at 0, 0. The initial side has to be on the positive x-axis, so the first side of an angle needs to be on the positive x-axis, okay? That is called the initial side. So I'm going to go ahead and label that as initial side. Okay. Now, positive angles go up and to the right, up and to the left, which is counterclockwise. So the opposite the way a clock does. So they go up and to the left. Those are positive angles. This would be considered the terminal side. That's where it terminates, okay, or where it ends. It's the ending side. So positive angles, when you're going around a full circle, right, if you think of the major angles, there's 90 degrees, 180, 270, and then a full circle is 360. But obviously you can keep going multiple times around, and there are angles that are greater than 360. There's also angles smaller than 0. And to graph those negative angles, we have to go down and to the left. Okay, so then your initial side obviously always has to be on the positive x-axis, and your terminal side is your ending side, right? Because every angle has two rays. So negative angles rotate the way a clock does, so down and to the left. Now, one of the things I just realized is these angles are not correct. So this is 90 degrees here. This would be negative 180, and then this would be negative 270. Okay, so do you see how, and then a full 360 around. So negative angles go down and around. So the first angle you would hit would be the 90 degrees down here. So do you see how the 270 and the 90 kind of switch spots? Okay, so for negative angles, you're going to go down into the left. It'll be negative 90, negative 180, then negative 270, and then negative 360, full circle. Okay, now we want to draw each angle in standard position and state the quadrant it's in, and wherever the terminal side lands, that's what quadrant we're going to say it's in. All right, so I noticed that the first angle is positive, so I'm going to go ahead and label where 0 and 360 are, and then 90, 180. This is just to help me figure out approximately where this angle is. So 194 is not too much past the 180 mark, right? So 194 minus 180 is only 14 degrees away. So just so you know, 45 degrees, right, would be half of 90. So imagine these are 45 degrees lines, right? So I don't want to go too much past the 180 because halfway between 180 and 270 would be 45 degrees in, okay? So you want to draw it a little bit closer to the 180 mark, but first you want to put your vertex, you want to put your initial side, and then you want to rotate down and around, but not too far, and I feel like that's still too far. You don't want to go too far past the 180 mark, okay? We don't expect these to be perfect, guys, but we do want you guys to be as exact as possible. Now, the terminal side, remember, so this is initial. You don't have to label them if you don't want to, but I'm doing it for the purposes of review. The terminal side decides what quadrant the angle is in, and that is quadrant 3. All right, so for negative angles, remember, you go down and to the left. So this would be negative 90, negative 180, and then negative 270. So remember I said previously that this would be like the 45-degree mark. So 68 is a little bit past that, right? So I'm going to have it be like right around here. That's what I'm going to label it as, negative 68 degrees. So use the 45 angle mark to kind of help you. You know what I mean? Okay, so negative 68 degrees, that ends up in quadrant 4. .375 is bigger than a full circle, so we're going to have to go a full circle and then some. Now remember, each of these spaces are 90 degrees, right? So this distance from here to here is 90 degrees. So we don't want to go too much past the 360. We just want to go 15 degrees past that. So 375 minus 360 is 15 degrees. Okay, so we only want to go about 15 degrees past the 360. So we need to show that we go a full circle. Now remember, positive angles go up and around to the left, right? So up and to the left, 180, 270. We're going to go a full circle and then 15 degrees past that. So just a little bit past it. And the way we show that is you draw a full circle and then some. So it almost looks like a coil, like this. And that's what you do essentially depending on how many rotations you have. Okay, so I want a full circle and then some. That's 375. That ends up in quadrant 1. And then last but not least, we've got negative 210. So this is a negative angle. So we're going to go down and around. So 210 is actually closer to 180 than it is to 270, right? Because 210 and 270 are 60 degrees apart, but 210 and 180 are closer. So I'm going to draw it so that my angle is a little closer to 180 than it is to 270, right? So 210 minus 180 is 30 degrees. So we want to go about 30 degrees past 180. And that would be negative 210. That would be in quadrant 2. So again, make sure that your initial side is always on the positive x-axis. You're going to go up and around to the left if your angle is positive, and you're going to go down and around to the left if it's negative. If you go around multiple times, you need to make sure that it looks like a little coil. Okay? Show how many times around it's gone. All right, this next one is reference angles. So we use a symbol called theta prime. So this symbol of theta with a little apostrophe there is called theta prime. Theta prime. And many textbooks and other classes use theta prime to signify a reference angle. So there are a few things you need to remember about reference angles. They always are made from the terminal side to the x-axis. Okay, always from the terminal side to the x-axis. And they are always positive and acute, aka less than 90. So in order to find a reference angle, you need to have an angle to start with. So the starting angle is 203. Okay, so 203 is a positive angle. So when I'm graphing it, or when I'm drawing it, I usually ask myself, okay, well, where would it be? It wouldn't be to 270. That's right. From 270, 203 is farther than from 180. So I do 203 minus 180, borrow, and then that's 3. So that's 23 degrees. Notice this is all no calculator. So about 23 degrees past the 180 mark. That's my normal angle. That's the 203 degrees. But my reference angle is from the terminal side to the x-axis. And there's two angles here from the terminal side to the x-axis. Do you see it? I want the one that is less than 90 degrees. So I'm going to want this guy right here. Okay, that little piece right there. So I'll color it in. So that's the reference angle right there. Okay, that's theta prime. And you can color it in if you've got highlighter. You can just use little angle measures. Okay. Now, remember the angle of 203 was just past the 180, and that's what a reference angle is how far is it from the x-axis. Okay, so another way of thinking of it is how far, or we'll put distance in a way. Distance in angle measures to the x-axis. As long as it's less than 90 though, okay? So remember there were two options here, but we wanted the smaller angle to the x-axis. So we already found that. That would be the 23 degrees. That's my reference angle. How much past the x-axis is it? All right, the next one is a negative angle. So remember, negative angles go down and around. So my initial side would be here, and then it's going to be pretty close to the 90, but not quite. So this is a negative 180. Now, the terminal side to the x-axis, it always makes two angles, okay? So there's from the terminal side to the x-axis this way, and from the terminal side to the x-axis this way. We want the smaller angle. We want the smaller angle. So essentially, you're trying to figure out how far the terminal side is from the x-axis. Well, your answer cannot be negative. Sorry, it was bothering me that line was so crooked. Okay, so your reference angle can only be positive, and it has to be less than 90, between 0 and 90, okay? So reference angles can only be positive from the terminal side to the x-axis, that is 80 degrees. Okay, so think about it. It's from the terminal side to the x-axis, right? That distance is essentially 80 degrees. Drop the negative because reference angles are not negative. Okay, 400 is positive, so we're going to go around and then some, right? So it's a full circle and another 40 degrees. So we're going to show that we went a full circle and then another extra 40 degrees. So take a look at that terminal side. That terminal side creates two angles to the x-axis, this one and this one. You want the one that is less than 90. You want the one that is acute. So that is what we need to find as theta prime. I forgot to put it here. Boop, theta prime. Okay. Well, remember we said that this angle was a full circle and then an extra 40. So that terminal side is 40 degrees past the 360. That's the reference angle. Remember, you can pause the video, rewind, and if something doesn't make sense, and you can also ask us when the next time you see us in person. Okay, we've got negative 90, negative 180, negative 270. So 257 is closer, right? Or sorry, negative 257 is closer to 270 than 180, but we need to know how much past the 180 so we could draw it, right? So you want to do 257 minus 180. Okay, so 257 minus 180. You're going to have to borrow from here. Boop, boop, 15. Okay, so 77 degrees. Okay, so we're going to draw it. We're going to draw this angle so that it's down and around and 77 degrees past the 180 mark. Okay, you could have technically also done 270 minus 180 to see, you know, how far it was from 270, but I tend to stick to only 180 and the x-axis because that's how reference angles are measured anyway. Okay, so I always measure to the x-axis compared to the x-axis. Okay, so now the reference angle is from the terminal side to the x-axis. So it's either going to be this one or this one. But I want the smaller one, the one that's less than 90. So that means it's got to be this guy. So this is theta prime. Now remember, you can color it in, right? Or you can use the double angle mark that I've been using before. It's really up to you. I don't really care what strategy you use as long as you are using theta prime. Okay? All right, so how far is that terminal side from 180? 77 degrees. 77 degrees. All right, pause for a second and think about what we just did. See if it makes sense. And then we'll continue on. So remember, reference angles are always to the x-axis. They have to be less than 90, and they are always positive. Okay. Okay, so continuing on for the last topic that we want to review with you guys is coterminal angles. Now, the word itself, coterminal, means that they both end in the same spot, okay? So they're angles with the same initial and terminal sides, but they have different measures. Now, to find them, so I hear this expression all the time. Have you heard the expression where people are like, oh my gosh, he's changed so much, he did a complete 360. So when you do a 360, that means you end up in the same place you started, okay? So let's say I started here, right? So this is my starting point. And I go around full circle, then I end up where I started. So in society, when someone says they did, oh my gosh, he did a complete 360, that's actually incorrect if they've changed a lot. You actually are supposed to be saying they did a complete 180, because that means they're not in the same place they started, and they are now better or in a different spot than they were. Okay, so let's say someone was doing really bad, but if they do a complete 180, now they're doing really good, right? So going 180 takes you to the opposite quadrant in a way, right? But coterminal angles, you do want them to end up in the same spot, okay? So they have the same initial, and let me get my coordinate. Here we go. Same initial and terminal sides. So that's important. But they have different angle measures. Now, because you want to end up in the same spot, you do want to do the full 360, kind of like why I was saying that people misspeak when they say, oh my gosh, he did a complete 360. That means he's exactly where he started. Same place. That's what you want with coterminals. Wherever you end up, that's where you want to be again, okay, when you find a coterminal angle. All right, so let's think of the angle 520, okay? So let's just graph it. Let's graph the angle 520. So 520 is definitely bigger than 360, right? So 520 minus 360 leaves you with 160. So we want to go a full ways around, and then 160, so almost to the 180 mark. So full circle, and then almost half a circle past that. So that's the angle 500. Okay, now think about what they're asking us. They're asking us to find another angle that ends up in the same spot. So all you have to do is either add or subtract 360 to the given angle till you find a positive and a negative. So notice the directions say find one positive. I'm going to color code here so I can show them on the, so they want one positive coterminal and they want a negative coterminal. Okay, so my positive coterminal, technically I've already found it by doing 520 minus 360. Remember, you can add or subtract 360 to the given angle to find this. So 520 minus 360 is, 520 minus 360 is 160. And if you notice, if I were to graph the angle 160, that would end up in the same spot. So my positive coterminal angle is 160 degrees. Is that the only one? No, I could have also added 360 to 520. I could have done 520 plus 360, and that would have ended up in the same spot. Okay, so just as a warning, there are various infinite answers for number 9. Because I could just add 360 over and over and over to 520 and give another answer of another angle that has the same terminal side. Okay, now let's think coterminal, right? I started with 520, I subtracted 360, but I ended up with a positive. So I'm going to take that 160 and I'm going to subtract 360 again. So I'm going to, go a full circle less. And then finally that gives me a negative answer. So the angle negative 200 is a coterminal angle because look, negative 200, so let me use green. So the negatives would have been negative 90, negative 180, right? This would be the negative 200, 20 degrees past the 180. So again, just know that when they ask you for just a positive or a negative coterminal angle, you can add 360 over and over, or you could subtract 360 over and over, and any of those answers would be correct. So if I subtracted another 360 from 200, that would also be an acceptable answer. But let's not get crazy, okay? Let's try to do the least amount of work. Subtract 360 until you've got a positive, subtract 360 till you get a negative, or add 360, whatever it takes, okay? So you find a coterminal. So again, I could have added 360 to 520. That would have been fine. Now we have essentially the same question here, except they're giving us a specific window within what the coterminal has to be. So they're saying, give me a coterminal angle that's between 0 and 360. So they don't want any negatives. They don't want anything past 360. All right, well, negative 280, so I'm going to graph that first. So it's negative, so we're going to go down and around. Okay, so it's just a little bit past the 270 mark, right? That's the negative 280. And I want another angle that ends up in the same spot. So I don't want any negatives, so I'm not going to subtract 360. I'm going to take my 280 and I'm going to add 360. Okay, now this is no calculator, so when you're adding positives and negatives, you're actually going to subtract them. So 360 minus 280 is 80 degrees. And if you look, so let's say I call that my positive coterminal, because look at that lands within my interval of 0 to 360, right? Ta-da! There's my coterminal angle. Now, if I keep adding 360, then I'm going to go outside of my interval, outside of that window, okay? That's like a restriction. Again, I didn't subtract 360 from 280 because that would not fall within the 0 to 360, but I can add 360 only one time. That gave me 80, and I have to stop there because if I keep adding 360, I'm going to go outside of that window of that interval. All right, guys, as always, if you need any extra help, feel free to reach out, okay? Good luck on your homework. Have a great day.